All right, welcome to this week's lesson number 8. Let's start off with problem number 1. Here we have an individual that's heterozygous for the following inversion. I've written the normal chromosome and the inversion chromosome already replicated for us. And I reversed the order of the inversion chromosome, just flipped it around so that I could line up the sequence here that got inverted. So we have a little crossover that happens here between S and T. So I'll draw a little line right here. This is right where the crossover happens. So we'll have 4 gametes that result from this. Product 1 will just be the normal chromosome like this. For product 2 and 3, at our crossover point, we'll just flip these 2 ends of the strands, which will give us our second and third product right here. You'll notice product 2 is dicentric and product 3 is acentric. Our last product, we won't do anything to our last chromosome. It's right on the end. So we'll just have our normal inversion chromosome like that. So these will be our 4 products for the heterozygous individual.
For question number 2, fill in the blanks. A non-disjunction in meiosis 2 produces 50% aneuploid gametes, whereas non-disjunction in mitosis can produce a mosaic phenotype. B, meiosis in an individual who has suffered a paracentric inversion produces a dicentric chromosome and an acentric chromosome. C, Turner syndrome is an example of human disease caused by monosomy, while familial Down syndrome is an example of a disease caused by Robertsomy and translocation. D, human liver cells can be 4N, 8N, or 16N. E, terminal deletion in chromosome 5 causes Cri-du-Chat syndrome, while an inversion on the X chromosome causes type A hemophilia. F, a duplication is a change in chromosome structure that can be potentially beneficial to an organism or an entire species. G, when a translocation cross is formed, the alternate segregation pattern can produce viable gametes and offspring. Moving on to question 3. Part A, how many total chromosomes would be found in humans that have the following conditions? In Turner syndrome, individuals with Turner syndrome, they would have 45 chromosomes. Jacobs syndrome would be 47, Cri-du-Chat would be 46, familial Down syndrome would be 46, and type A hemophilia would be 46. Part B, which of the following terms is not associated with Charcot-Marie-Tooth disease type IA? The following ones would not be, which would be triploid, aneuploid, reciprocal translocation, trisomy, and non-disjunction.
So part C of number 3 asks which of the following terms are associated with Klinefelter syndrome. Remember, Klinefelter syndrome is a condition and that's XXY. So which terms are associated? Well, that would be aneuploid, trisomy, and that is caused by non-disjunction. So aneuploid, trisomy, and non-disjunction. Part D says, which of the following terms are associated with type A hemophilia? And we were looking through this list, and really none of them, our answer is just none. None of these terms in Part D are associated with type A hemophilia. So let's jump into question 4 real quick. I'm going to have to write these guys up here real fast. D, E, F, G, H with the centromere, I, J, K, L. And then I'm going to N, P, centromere, Q, R, S, T. So D, E, F, P, centromere, Q, R, S, T. And then N, O. G, H, centromere, I, J, K, L. So let me just label these for you real quick. I put both normal chromosomes in my corners, normal, and these ones are my reciprocal translocations, RTs, up and top. And if you notice, these are going to be the sections that get translocated. P, Q, R, S, T, through the, well, I guess, CHIEKL. So corresponding switch happens right there. Now, part B asks us, in this reciprocal translocation, if we were to do an alternate segregation, what would be the allele composition of the gametes? So there would be two different cells. We'll make a note this is alternate. We're going to have cell 1 and then cell 2. So in the alternate pattern of segregation, these diagonal chromosomes are going to end up with each other. For cell 1 is going to have both normal chromosomes, E, F, G, H, I, L, and then O, P, Q, R, S, T. So the first cell has both of the normals. Let's get our reciprocal translocations in there. D, F, P, centromere, Q, R, S, T, followed by M, N, O, G, H, I, J, K, L. So that'll do it for part 1. Those are your alleles in the two different cells for the alternate pattern segregation. Part C asks us for the adjacent, let me spell that right for you, adjacent 1 pattern segregation. Now in the adjacent 1 pattern, we are going to draw a line as if it were a plane separating these way, separating that way. Both chromosomes on top are going to go into one cell, both on the bottom will go into the other. Cell 1, cell 2, we are going to have D, F, G, H, centromere, I, J, K, L, followed by M, N, O, G, H, I, J, K, L, followed by D, E, F, P, centromere, Q, R, S, T, M, N, O, P, Q, R, S, T. Fix my T right there. So if you notice in this pattern of segregation, the back half of the chromosome will stay the same for both of them, or both offspring. The only thing that really changes is kind of the front half. Same thing up here. Back half seems to stay the same. Front half is going to switch those 3 letters. So that'll do it for part C. These are little frequencies for adjacent 1. In part D, it's asking us for adjacent 2. We're going to erase our line right here. And adjacent 2 is the least common of all of these segregation patterns. And then we're going to split it down the middle. Everything on the right will go in one cell, on the left into another. Cell 1 and cell 2 will have D, E, F, G, H, centromere I, J, K, L, followed by D, F, P, centromere Q, R, S, T. Let's move forward. M, N, O, G, H, centromere I, J, K, L, followed by my other normal chromosome, M, N, O, P, Q, R, S, T. And there are your allele frequencies for the adjacent 2 pattern of segregation. And that will end number 4, and we will move on to number 5.
All right, for number 5, it says cats have 38 total chromosomes. So how many total chromosomes will be found in the following types of cats? For a triploid cat, they'll have half again as many chromosomes, since they'll have 3 sets instead of 2. So that'll be 57 chromosomes. Cat that is monosomic for chromosome 12, that means they have an extra chromosome 12. So they'll have 37. That means they have 1 less chromosome 12. So they'll have 37 instead of 38 chromosomes. A cat that has a terminal deletion on chromosome 7, that won't change the total number of chromosomes, so it'll still have 38. If they have a Robertsonian translocation, that means chromosomes 17 and 18 fuse together, so they'll be short one chromosome, 37 chromosomes, even though they won't have any less genetic material. A cat that has a reciprocal translocation, that also won't change the total number of chromosomes, as long as both their translocations are paracentric. If one of them's pericentric, so including the centromere, then you could have some things messed up. You could lose some chromosomes there and have 37 or 36 chromosomes.
So thanks for joining us today. See you next time.